But
That
how
infill shading will be changed when we compress it.
that will not be too much. No? It will be clear.
Yes, sir, little bit.
Little bit it will change, but not too much. But at least we will have all the record at one place, and for us to correct also it will be easier for us. That's the reason why.
Yes, sir, we also will get marks easily.
Yeah, that way that you can see your marks after every lab. So that
What
would.
Satish, I didn't get you about that shading thing, which I didn't understand.
Which one? Can you repeat?
Like he asked us something in figure or something will be problem. I didn't get that problem. That's why I'm
Yeah,
asking.
mostly he says that the quality of the figures will go down. That's what he said.
Oh, okay, okay.
Generally, a little bit of change will be there, not much. You cannot. It's not very conspicuous. You cannot see that. Okay. So enough of time we have waited out. So what is the strength now? Not 4. So that's good enough number. So we will directly go to our lab today. So how many TAs are there today?
Good afternoon, sir. I'm Jain Anil Kumar, sir.
Anil Kumar. Okay. Next one.
Sir, Sandeep, sir.
Sandeep Mantri.
Yes, sir.
What happened to Sandeep? You are not joined last week.
Sir, I mean, in between the journeys, I'm coming to the campus back. So
You should inform him,
couldn't.
Sandeep. You cannot do those such things, right?
Yes, sir.
You
So,
are
sorry,
joining.
sir.
It's
Sorry.
okay. That's okay. But you just inform. So that you know.
Okay, sir.
And then Sandeep Anil is there. And
Good afternoon, sir. My name is Venkatesh Varlu.
Sahit is there. Sahit is there. Venkatesh is there.
Yes, sir. Venkatesh.
And another
Sir,
one is
Sahit.
Venkatesh Nalla.
Sir.
Yeah. Any other?
Sir, Sahit Chavar.
Sahit?
Chavan.
Okay.
Yes, sir.
Any? So total 4 plus 3, 7. One is missing. 8 people. Na?
Hello, sir.
Yes. Who is it?
Hello.
Yes. Who is it? Hello. Okay.
Hello, sir.
Yeah.
Sir, Soumya, sir.
Soumya Rajantosh. Okay. Students, my small request is don't switch on the system and just leave. We want to discuss something last week also at the end of the system, and you've been leaving the system without closing your account. But don't do that, please. Leave the meeting as soon as that is over. Okay. So last class we have already completed our first experiment. Okay, and this week we will try to look at the second lab, which is torque measuring using strain gauges. Okay, so what do you mean by torque measurement? Torque, you know that it is the force applied perpendicular into the product of the perpendicular distance from the fulcrum or the center, right, where the load applied. So here what we are essentially doing is for measuring this torque, the advanced equipment is strain gauges. Okay, we will see how the strain gauges work and all, but generally strain gauges are being used. The principle of strain gauges is we will have very fine wire or metallic foils, just like what you are seeing over here. Very fine thin wires are to be here, and they are arranged in the form of a grid. Okay, you can see over here. You could see here. My cursor is visible, right? So you are seeing here that there is these fine wires are arranged in the serpentine path like this, and this all will consist of one particular resistance, and this one is another resistance. This is another resistance. Like a Wheatstone bridge circuit, they will be created. Okay, it is converted in the form of a grid pattern. And whatever the strain, mechanical strain that we are applying on the body or on the surface, it will induce a compressive strain in two of the grids and a maximum tensile strain in other two arms of the crate. So that the resistance, there will be a change in the resistance of the circuit, which will be noted down in the circuit as a voltage difference. So essentially what we are trying to do is, whatever the mechanical strain we are getting, okay, because of the torque that we applied, that amount of, you know what is strain? Strain is the change in length to its original length. It may be compressive length or it may be extensive length. It may be positive or negative. So when we apply some force, the material tends to change or distort. When it distorts or changes its shape, there will be change in the dimensions of the instrument, and whatever the change of that instrument to its original value is what we call it as strain. So here, because of the torque, that force whatever we have applied, there is a change in the there is a induced deformation in the material, and because of the material, we are actually sticking a fine metallic wire of this particular shape, whatever we are seeing it here. So, and this is connected to an electrical circuit where when there is no load is applied, there will be zero value, and when you apply some load, it immediately shows down certain voltage. Okay, so this is the basic working principle of a strain gauge. Okay, this is very important, and even for the smallest changes in the forces, we will try to utilize this particular strain gauges to measure the applied force. So we call it as a load cell also. So generally, that is what we are trying to do. Okay, so we can see over here, I just produced here that it is designed for torque measurement as a Wheatstone bit circuit, where we have four element circuit configured in a diamond shaped thing like here. And we see that there is excitation voltage will be applied to the gauge, and then sense voltage V0 is measured as an output from the gauge. So whatever the resistance, because of the resistance, what is the output voltage that is happening is given by this particular equation. So R3 by R3 plus R4, similarly R2 by R1 plus R2 into the excitation, whatever the excitation voltage that we are giving. So that will give you the output voltage, what we are going to do. So when we apply the load, whatever the changes that are happening in the resistance of these four resistors, so that we will keep it in this expression, and we know the exponential excitation voltage. So from that, we will get the voltage output, and from the measurement of this voltage output, we will be able to measure what is the torque. Now the question is, suppose if you applied some load, you have applied some load or some force, and immediately it is giving a voltage V0. What is this V0 corresponds to? How do you ensure that the voltage output that we are getting is analogous or is the measure of certain parameter called force? So how much that force? So we need to have a calibration chart for that. So first we need to understand what is the applied force, and for the known applied force, again I'm repeating, for the known precise applied force that I have applied on the shaft, there will be a change in resistance which will further induce a voltage change. So since I know the how much force that I have applied, and I also know how much distance from the center I have applied, I will find out the torque. Torque is equal to F into R. So from that, you will be able to find out a relation between the torque and the output voltage. So that is a simple principle that will be used in a strain gauge. So time and again, whenever we want to use the strain gauges for measuring the torque, first what we have to do is we need to find out the induced voltage is referring to a particular known value. So what is the relation between the output voltage and the actual force? That is what our torque, that is what we need to find out. So this experiment will help you to understand how that process will be done. Okay, so that is what we are going to do in this particular thing. Now, when I applied load, I am showing a small shaft where I'm applying some torque on the this side. Okay, there is a red color clockwise direction applied shaft. So when I am applying a torque to a shaft, what is happening is you can see that there are in 45 degrees, there are two planes which we will call as principal planes. where you can see that there will be elongation in two directions because of this torque. You can see that there is maximum elongation this side and this side, but in the similar way, there is a contraction in the other two sides. Okay, so because of the elongation of the, because of the change in length of the wire, there is a change in the resistance, and that resistance will be shown in the form of output voltage, and that output voltage corresponds to the torque that is applied, which is basically the form of force. Okay, so this is the fundamental principle that we are using. So in general, this is what you will see in a load cell. If you see the experimental setup, what is inside the shaft is this one. So you have this circuit. It's like a sticker. You will take that sticker kind of a thing, and you will make sure that there is no dirt, nothing on that, and you just stick that to the surface of that particular shaft. And based on these connections, you could see that there are terminals which will go into the data acquisition system, where you are actually measuring the voltage. Whatever the output from this will be connected to the output voltage, and for measuring the output voltage, we will connect the circuit to that. Okay, so the four arms of the unstressed. So when we are not applying any torque, when we are not applying any force, since we are not stressing, so the strain gauges are equal in length. These are all equal in length and thickness. So they have the same electrical resistance everywhere. So you will not see any output voltage. Whereas when we are applying some torque over here, it will tend to increase. So when you are applying, especially for torque, what you need to find out is the arrangement, how you are arranging this. This may be arranged as a plus like this, like a plus you can do. But here if you see this, it is made into four elements like X, Y, to make sure that the strain gauge is aligned along the principal plane, which is 45 degrees to the horizon. So that whatever the change in the dimension is happening, there will be two resistance will be experiencing a maximum or increase in length, and two resistors will be observing a compressive force. So because of that, so two lengths, two of the arms are stretched longer and they become thin. Okay, and two become shorter and they become fatter. So because of that, there is a change in electrical resistance, and this resistance change is exactly proportional to the torque on the shaft, and we can measure it accurately by using a bit circuit. So this is the essence of the what we have is a strain gauge. Now we apply some force, we will be able to find out the output voltage with the help of changing the resistance of the wires. Okay. Now I just wanted to show you how this strain gauge will look like. So this is the shaft. You could see a shaft. See now on the right hand side here, this is all dirt, right? So initially this whole shaft is like that. Now before actually applying this onto the shaft, they have made sure that there is no dirt, rust or anything on that. It is completely perfectly touch with the surface of the shaft. So for that, they will do a lot of procedures. Like first, initially they will polish it. They will polish with the polish paper, and then they will use some chemicals to make sure that there is no rust particles, no oxidation is happening. So after that, they will take these strain gauges. If you can see that strain gauges circuit. So 1, 2, 3, 4, 5. These are the 4, 5 terminals we have, and the small, very small. You can understand how small the strain gauge will look like. It will be in few centimeters, 2 by 3 or 2 by 4 centimeters. That's it, nothing more than that. So that much smaller values it will have, smaller dimensions it will have. So in that, if you see that here, it is just stick to the surface, and in the next figure, you can see when the terminals are connected to get the respective voltage output to the data acquisition system. Okay, so this is how you can see nearly how this particular thing will work. Any doubts in this? I hope it is clear, right?
Yes.
So this is the introduction to these strain gauges. Now we will have a look at I will show you how this actual resistance will work. I hope the voice is clear.
Yes.
This is made by IEICOS Manufacturing Systems. Hello everyone. This is a torque demonstration system. So that means we are actually measuring the torque using a strain gauge. So many of the industrial applications we will use this electronic equipment called the strain gauge to measure the torque also. So but how do we ensure that whatever the measuring instrument, the torque measuring this strain gauge, that whatever the values that we are getting are true or not? Over a period of time, all these electronic and mechanical devices, they'll have frictional effects and all. So they tend to have some uncertainty or error that is creeping into the system. So what we need to do is, again, time and again, we have to calibrate that. So initially, when they prepare this strain gauge also, they have to ensure that it is actually showing the correct values. Okay, so there are two things. One is ensuring that it is measuring properly, and over a period of time, we are also looking at whether it is giving the accurate results or how much error is there in between the actual standard value and the measured value. So for this, there is a small setup they have made. It's a very simple setup. We have a frame over here and the strain gauge they have already fixed to it, and to the end of the strain gauge we have already fixed a bar which is of 1 meter length from here to here, from the strain gauge to the end. Okay, now we know that these are the reference weights, which are, we know that these are standards which are of, each one is of 1 kg weight. Okay, all these bars. So now you know that when I put a weight over here, this is 1 meter and the weight is and the mass that where I am putting it is 1 kg. So automatically your torque will be 1 kg meter. Okay, but we also finding that 1 kg meter has to be shown by the strain gauge, and for recording this we do have a digital indicator here. You can see that there is a digital indicator where, since we don't have any weight over there, it is kept to zeroed position. Okay, now what we need to do is, we know manually from our calculation, suppose if I put here this 1 kg bar, okay, suppose if I put 1 kg, it should show 1 kg meter. For the time being I put 2 kgs. Okay, now the torque that is applied according to the principle is 2 kg meter, and you can see from the digital indicator it is showing 1.63. 1.63. Okay, so there is a difference between the torque that is measured, that is actually measured, and from the strain gauge that we are getting. So one thing is, when we are buying it, we should know from the purchaser also how much is the error that will come from the instrument, measuring instrument. So to ensure that this kind of experimental setups will be used. Okay, now we have 1.62 for 2. Similarly, I am putting another kg, another 2 more kg of weight, that will make the values. Now I put 3 kg, now it is showing to 2.42 around. Okay, and the value is, here is 3 kg and it is showing 2.42. Again I am putting another weight over here. Now it is showing how much? Now 4 kg meter, but our digital indicator is showing 3.2 kg meter. If you record it properly, I have told you, you might have studied in your mechanical measurements class that there is a loading and unloading effect. That means when you are loading, when you write in between, when you draw the graph between the reference value as well as the measured value, while loading and while unloading, while taking out the weights, you don't get the same value. There is a slight difference in the system values or in the measured values. So that we call it as a hysteresis effect. Those are the residuals left over. So you can also observe that now we have loaded it and we can find out the errors or the differences that we are getting from the two standard as well as from the reference or measuring value, and from that you can have a loading curve. And then when I am taking this 1 kg out, this is unloading. Now I am taking 1 kg out. So now 3 kg, earlier it is showing around 2.4, now it is showing 2.33, 3.32. So it's not the exact value, there is a slight variation while I load and while I unload. So you have to measure those values also. Take 1 kg out and again measure that value. Okay. Likewise, you will get a graph for which you'll put have a loading curve as well as an unloading curve. So from this, you will also it also gets demonstrated the hysteresis effect out that is coming from the this strain gauge, which is used for measuring the torque. Okay. So this is it. Thanks. Any questions? Yes, any questions? I'll be happy to take.
No, sir, it's very clear.
It's clear, no? So now we will have a look at the. So this is the manual that is already shared with you. Okay, you can have a look at it. So here we have talked about the strain gauges, what is happening when you apply load and all. So why we are keeping in that direction. The procedure is also given, and what you need to ensure is you have to, for the given loads, very simple experiment. So what you are trying to do here is the two loads are given to you. Okay, already done experiment. So what is the actual load that we are applying? Okay, and how the digital pressure indicator is reading. So when you apply zero load, while loading, that means when I am going on increasing the weights, okay, in certain fashion, in a regular pattern. So when I put zero, it is showing zero. There is no load, it is showing zero. When I put 1 kg, it is showing 0.85. When I put in 2 kg, it is showing 1.68. Similarly, third, 2.49. Likewise, it is not giving the exact value. Okay, there is a small change in the value. So you will plot those two curves. Okay, so this is I upright up to 7 kg and then 7 kg meter, and then after applying that, I'm left with 5.6. So when I'm going to take that out, I will be getting, instead of 6, I'm getting 4.55. When I put 5, I'm getting 3.75. So there is a huge difference. Almost 1 kg meter is a difference, almost 0.8, 0.9 kg meter difference is there. So that means the torque meter or the load meter is not, load cell is not maintained properly. That is the question. So there is no maintenance over here. So that may be one of the reasons why we are not getting the correct values. So what we need to do is, you might have also seen in the digital reading that there is a negative value that is coming, which in general it should not be, but it is showing. So because there may be some errors that has crept in, so we have to maintain it very properly. So for section A, you can take this, draw the,
Doubt.
yeah.
Sir, I think negative means anti-clockwise, right?
Negative means?
Anti-clockwise, because if we apply clockwise, we will get the same reading, but
But
in
here we are
positive-
only applying loads only, no? How do you say that which direction it is rotated? You are finally ensuring that in one direction only you are rotating. Suppose if the shaft is in the other direction, it will, as you said, that it will be clockwise. Now, in which direction it will move? It will move in the anti-clockwise direction, right? So
Yes,
very
sir.
small torque. So that doesn't make any sense. So that is the point. All right. So generally, these display boards and all, they will have this positive and negative, and if these connections are loose and all, there may be small loose connection in the terminals that is actually creating the negative value. Okay, you need not worry about that. But I'm saying for the sake, if you are here, you will be observing that. You may ask me. That's why I myself is asking and answering. All right. So the important point is when I take the complete load also, it is showing 0.14. So even after taking the load, because of the frictional things and all, it is showing 0.14. So some error is being there. So what we do is we will draw two curves. Okay, one is while loading with actual values and then applied torque meter values. And then when you are applying when you are taking out, there is another curve which comes as unloading. If you remember I will show you. So what I am talking is, suppose you have, this is the curve. Is it visible?
No, sir.
I have to switch on to this, I think. Just a moment. Now it is visible, right? So what I'm saying is, I am trying to say that while loading, will be like this. Curve will be going like this. Okay. These are for different loops. This is from 0 to 7, for example. So the ultimate thing is like what we expect is even when you are measuring 6, okay, it should be exactly 6, but it will be showing some 5 point something. It is around 5 point something. Okay. It is supposed to be 6 and it is showing only 5 point something. But at least the same value should come when I take the weight, but instead it will follow smaller curve like this. Okay, so this is basically your loading curve. So basically your loading, and this is unloading. So now if I want to take a relation between these two, so this is from the torque actual values, this is from the digital values, from the digital values. Okay, from the digital values. Digital recorder values from the strain gauge. From strain gauge. So which one you have to take? Either this curve or this curve. Loading curve you have to take or unloading curve. So the loss here is this is the hysteresis loss, if you remember, a particular location. What is the loading time, loading value? What is the unloading value? Now, which value you have to take?
Average.
Average of these two probably will give you the best curve. That is the use of this particular. So now from this you will get either if it's a linear, you find out y is equivalent to mx plus c format. Okay, so from this you will be able to find out what is your input for a given input, what is the digital output that you have got. Or you are getting a digital output value here, what is the exact value x? Y minus c by m, that will give you the x value, whatever the exact value, whatever the digital reading is showing. Now when you use, when you apply some unknown load, it will give you some digital value. So that digital value, if you keep it here, then y minus c by m will give you the exact value that we are supposed to measure. Clear? Any questions? Someone is listening to some other class. Clear? Any further questions, guys? Is it clear? So what you need to do is you need to draw Saujanya. Saujanya, please switch off your YouTube. Any questions, guys, in this? So everything is available on the video that I have shared in the folder that I shared with you. So you can have these values. Any further thing, and you have to submit this by next Thursday afternoon. Okay, it's a simple thing. It's not, there's not much to do. But only thing is I want you to write something new rather than what you see in the observation. Okay, something you try to find out. One question is basically what is the advanced torque measurement systems that you can see. So that question you answer. Okay. Now this is a strain gauge. Suppose if there is a body which is rotating. Okay. What are those that are there? So some of you please write down in 1 or 4 or 5 basic thing and then working principle of it. At least one you write down. Okay. Is it clear what I'm asking? At the end of this particular project report, okay, just what are the advanced things? Suppose this is only for applying certain force and then what is based on that? Suppose if the complete thing is rotating, okay, how do you measure the torque? There are many advanced things like we have find out in the website. So there are basically wireless technologies we also have. So there is no wire connection. There is wireless communication between the shaft and as well as the data acquisition system, and from that you are measuring them. Okay, So just find out something in half paragraph also, not much, just name that and then write the working principle with a sketch or something. So that will give you some extra marks. Those who don't want, don't write. It's up to you, but marks will not be available for that. So 2 marks will be for that question. Okay. Anything more? Should I stop for today?
Sir, in the readings,
Hmm.
all the unloading values are lesser than the loading values, but except the first one, when the
Yeah.
zero.
Yeah.
So we should consider that, or we can
You
ignore that
consider that.
value.
You consider that. There's no wrong in that. Okay, generally you studied in mechanical measurements, instruments after putting weight and taking over a period of time, they will not show correct values. It will not show exact zero. Okay, it will show some kind of insensitivity. So it will not zero error, we call it as. Just go and
Yes, sir.
see. Drift, we are calling it the drift or zero error. So it will not exactly come back to zero. Okay, that comes under that.
Okay, sir.
Hope if everything is fine with this, today we will stop the recording and I will share this by today evening or tomorrow morning. Any further questions in this, I'll be happy to answer. Those who doesn't want any answers or questions, they can leave. This lab is good, no? In half an hour, everything is getting completed. Isn't it? Only TS will be online, others please leave.
Yes.
Thank you, sir.